Let us start the class. Okay, so in the last class, we saw about the hand recognition system, which is very similar to the fingerprint system, but at the same time, the algorithm is slightly different. We saw in the fingerprint system, it is generally we are having some sort of minutiae or features or lines or ridges, and we do some sort of either a correlation mapping of these ridges and minutiae, or we do a minutiae matching. But in the hand recognition system, it's a different process. We are having the human hand, but that hand we are taking the image, we are cleaning it, we are filtering it, we are taking the contours or the border tracing. It is like, you keep your hand and you take a pen and you trace the border of your hand. Then we take some measurements and make a feature vector of the hand. If I recall, 16 measurements will be there in the feature vector. The width, 2 widths, 5 lengths, and 1 additional data point is there, and that is the fingerprint. And generally, hand recognition system. Hand recognition system is a little better than fingerprint in certain respects, but not in. It's comparable. They are not. You cannot say that one is better than the other. In certain respects, fingerprint is better. Certain respects, hand is better. But I think the FAR and all, definitely the hand will be a little better, slightly better, not much. FRR, I'm not too sure. I don't think it is. Maybe it's the way to try to check that out. But what I'm trying to say is that both these are generally good physiological biometrics. They are not expensive. They are easy to process. They are easy to have computational mechanisms, or storage is less. So they are popular. Now, today I am just slightly deviating and starting with one behavioral biometric, namely the voice recognition or the speech recognition system. Mind you, voice and speech are identical and one and the same. Some places it is voice, some places it is speech, but they are identical, one and the same. Now, voice recognition is a behavioral biometric which depends upon the voice of a person. The speech that is given by a person, the speech is recorded. Just like you are giving your fingerprint, your speech is recorded. That recorded signal is stored in the database. The next time you give the voice or the speech, again that speech is converted into a signal, and the original signal and the new signal are compared. But having said that, it is very easy, it is convenient, it is not intrusive. I already told you that when we are using fingerprint and hand, the problem of this COVID and infectious diseases issues are there, and it is intrusive, and it is contact is there. There is a contact of the human body with the device, which is, some people don't want to do that. So here it's a little better in the sense that voice recognition, that there is not intrusion. It is very convenient, it's easy to use. And the voices or the speech is converted to signals. It can be translated. You're using mobile phones, you're using LAN phones, voice over IP. It's very easy. It's very easily transmittable. It's very easily accessible. It's ubiquitous and so on. But it's a very big but, that voice recognition systems and speech recognition systems may not show high accuracy. And definitely their FAR, false accept rate, and FRR, false reject rate, will be very high. Now, the reason is very crystal clear. You know that human voice changes. When you are a child, your voice is different. When you attain adolescence or puberty, again your voice changes. As you grow older, the voice changes. When you are sick, with cough, your voice changes. When you're emotional, your voice changes. So all these issues are major challenges with respect to the voice recognition systems. Another major challenge is that, there are voice and speech, there are many multiple tones, multiple dialects, multiple accents, multiple pronunciations, all which make speech and voice recognition systems very, very complex. the acoustical model has a lot of complications, and that is the reason why they are not so accurate. Now, to just give you an example, there is something called a phoneme. A phoneme is the smallest phonetic unit in a language. So a phoneme is the basic unit of a language, but the problem is the same alphabet. The same alphabet is different in two different phonemes. Boy and toy, right? Boy and toy. There is a distinction in the words boy and toy, right? And each phoneme, of course, B and T, there is pronunciation is very easy. So the phoneme, there is not much of a problem. Boy and toy, there is enough distinguishing. I mean, you won't get confused. But when you use another phoneme like T in tab and T in stab, T in stutter, now the same T is used in three different pronunciation. T in tab is different, T in stab is different, T in stutter is different. So the pronunciation of that phoneme is different. And these are the complications that are there. Now, there are also complications with respect to accent, right? Accent and words. Just to give you a simple example, if you have lived in the US, you go to a petrol pump, you ask for petrol, he will not understand what it means. If you ask, I want some petrol, he will not understand. And you say, I want 5 liters or 10 liters of petrol, he simply will not understand both the words. He doesn't understand petrol, neither will he understand liter. He will only understand gallon and gas. Gallon or gas. So you say petrol pump in India, in America, it is a gas station. A completely different meaning. In India, probably a gas station refers to a place where you get this cooking gas cylinder. LPG cylinder, that is the meaning of a gas station in India. In America, it means it's a petrol, it's a where you get petrol for your car. And now you say that your weight is say 45 kilos or 55 kilos, you won't understand. In America, they use it as pound. Words have different meanings. Pronunciations are also very, very different at times, not so much though, but still pronunciations are also different. If you take Indian English, Australian English, American English, Queen's English, British English, there are all different. You know, a very popular thing that linguists use, you know, tortoise, tortoise. In India, we pronounce as tortoise, but the British, the Queen's English is tortoise. It's how they pronounce it, right? So these are the big challenges that are there. So the lexicon or the database is huge. There are different dialects, different pronunciations, different accents, different pronunciations, which make this system a very, very complicated system. It is very difficult to have a trellis. A trellis will be a data structure consisting of all possible allophones. When I say allophone, all meanings of the word, all pronunciations of the word, all different accents of the word, all different meanings of the word, all different phonemes are also there. Making this trellis is very difficult, and this trellis will never be perfect unless you have a multilingual kind of group that takes care of all these pronunciations and things, then only then. So that's a major challenge, and that is why the FAR and the FRR of the speech or the voice recognition is very high. And another issue that we have is there are also two different standards that are there for the voice and speech recognition systems. Voice XML and ASSAULT, but I am given to understand that today the voice XML is mainly used by the telephony companies, including, but with an exception of a IT company called IBM, using voice XML is very similar to the XML. It's an extension of the XML that we use in HTTP and web pages. Another competing standard which is mainly promoted by the software companies is SALT. Speech application language tabs. Microsoft, Intel, Cisco, or SpeechWorks are using. I am given to understand that now, at least for computing applications and all, SALT is now become more and more popular. But both the standards are there, and these standards are not going to go away. They have to talk to each other, and they have to become interoperable. So these are the major challenges that we have in speech technology. Two different standards, all the pronunciations, all the different meanings of words, all the different accents. In other words, making a trellis is a very complicated thing, and that is a major challenge. But with respect to the speech recognition system, the method is very similar to the image processing system. Although the pre-processing is a little different here, the system, the method or this thing is very similar. The steps that are involved in the speech or the voice recognition system is that first you have a speech. That speech is converted into a waveform, that it is captured into a waveform and digitized. Then that digitized waveform, we do some sort of spectral representation, removing certain layers, certain frequencies from that waveform. We do a segmentation of the waveform, do a phonetic classification, and you isolate the phonemes, and then you store it in the database, and that is the acoustical model. So first what happens is that you're capturing the voice, the speech. It is taking the input, it is taking in some frequency, that is 8,000 samples per second. It is stored in the database. Once that this telephony device will convert that voice or speech into a spectral representation, into an image, and then that image is segmented. The speech signal is converted into segmented parts to remove the accuracy. Noise is removed. So this is something like that. This is the signal, and then there is a spectral representation. Unnecessary voices are removed. Then we use it we extract the phonemes, the various phonemes, and then we store these phonemes, the value associated with that, and that is how the thing happens. So this is a very simple kind of thing. But having said that, I have already told you, there are inherent disadvantages. Primarily, the disadvantage is that all these complications are there with speech, and that is why the speech recognition systems are slightly not having very high FAR and FRR. For that matter, almost all behavioral biometrics are not having good FAR and FRR. All, including there is signature, right? You're putting your signature. You're using this computer keystrokes, keystrokes of your, even that is not a very good biometric. Both, all of these are behavioral. So generally speaking, we can conclude that these are the physiological biometrics are generally better than behavioral biometrics like voice, like finger signature, like keystroke dynamics. We will learn these two in the subsequent classes, and generally it is physiological biometrics are definitely better. And another thing is that these physiological biometrics, another thing about them is that they also are, you have multi-biometrics, and they become more and more better. Okay, now you can stop the recording, please. Let me take the attendance.